Today's topic is going to be the first in our Math of Chemistry unit, and it is called gram formula mass, which is abbreviated GFM. What is it? It's pretty simple. The mass of the formula in grams. Now, obviously, chemical formulas aren't going to weigh grams. There's going to be something else involved, and we'll talk about that in our next video. But for today, we're just going to use it in grams. Now, how do you do it? It's pretty simple. You take the amounts, you look at the amounts of elements of each type in the formula, and then you're going to take the masses off the periodic table and round them to whole numbers, and then you're going to add them up, and that's pretty much it. So for example, H2O has 2 H's and 1 O. H's off the periodic table when rounded weigh 1, so 2 H's weigh 2. Oxygen is 15.9, so it's going to round to 16 since there's only one of them. It's going to weigh 16, so if I add that all up, water weighs 18. And what we're going to say the units are grams per mole. The mole portion is the next topic we're going to learn, so for right now, just write the units down, and then I'll explain what they mean in our very next video. CH4, well, it's 1 C and 4 H's. The C's, carbon weighs 12 when rounded. Hydrogens weigh 1 when rounded. There's 4 of them, so they weigh 4. So this thing weighs 16 grams per mole. Glucose, or C6H12O6, there is 6 carbon, 12 hydrogen, 6 oxygen. So carbon weighs 12, 12 times 6, 72. Hydrogen weighs 1, so 12 of them weigh 12. And oxygen weighs 16, so 6 of them weigh 96. Add the whole thing up, 180 grams per mole. It is also should be noted that the GFM can get very large. You can have GFMs that go as high as 1,000, give or take, and they can be as low as single-digit numbers. So just because the number is 4 or 5 or 6 or 700 doesn't necessarily mean it's wrong. They get that large. There's just nothing you can do about it. So next one, this formula. So these types of formulas tend to be tricky. The main reason is because if you look, the H's are in 2 spots and the O's are in 2 spots. Now when we do GFM, we don't actually care about that. So if I look at this formula as a whole, it has 1 nitrogen, 7 hydrogen, almost missed it, 2 carbon, and 2 oxygen. So that's what I care about. So my 1 nitrogen is going to weigh 14, my 7 hydrogen, 7, my 2 carbon, 24, my 2 oxygen, 32, add it all up, 77. This next one, nitrogen is written twice, so there are 2 N, 4 H's, 3 oxygen. So we are going to get 14 times 2, which is 28, 4 times 1, and 3 times 16. Add it all up. This should be pretty easy. Now it gets a little more complicated here. If you look at this formula, be aware, this 2 outside the parentheses doubles everything inside the parentheses by 2. So I have 1 mg, because the mg doesn't get multiplied by 2, it's not in the parentheses, but I have 2n and 6o, because the unwritten number for the n means that there's a 1 there. We don't write the 1, same thing with the mg, okay, there's really a 1 there. And then this 2 doubles it, making it 2, and then there's 3 oxygen, and this 2 doubles it, making it 6. So now when we add all these up, I get 1 mg weighs 24 when rounded, 2 nitrogen weigh 28 when rounded, and 6 oxygen weigh 96. Add the whole thing up and I get 148 grams per mole. Next problem is this. So if you notice, the 5 is in front of the water. So what this is saying is I have 5 water molecules. So think of it like this. Like everything to the right gets multiplied by 5. It's kind of like in math. If you had, for example, let's say you had x plus 1, right? If I put a 5 in front, what it's really saying in chemistry is this, that there's parentheses around it, even though the parentheses weren't written here. In chemistry, we assume that a number to the left is multiplying everything to the right by that number. So the parentheses are pretty much, they're not written in, but it is implied. So it is a little different from math, but that's essentially what it does. So what it means is you have 10 H's and 5 O's. So we get 10 and then 80. Add it all up and we get 90. Now there is another way to do this. If you look at the very first problem we did up here, we know that water weighs 18. So since it's 5 times the weight of a water, it's really 5 times 18, okay, which is also 90. So you could have done it either way, you get the same answer, whichever way is more convenient for you at this point. This problem, so this 2 tells me I have 2 Mn. But everything in the parentheses is getting multiplied by 5. So that means I really have 10 CRs and 35 oxygen. So this is why I said earlier these numbers can get really big. So 2 Mn will weigh 110. 10 CRs will weigh 520. And 35 O's will weigh 560. Add the whole thing up. You get 1,190 grams per mole. Last problem. This problem is called the hydrate. So here's the common mistake everybody makes. Everyone thinks that this right here means multiply. In chemistry, we're actually going to add, because it's not really a mathematical operation. What it's actually telling you is that 5 waters got stuck to 1 copper sulfate, or CuSO4, whatever you want to call it. So it's really like saying these 2 compounds are connected but not bonded together. And so the way we treat it is like it's a plus sign, but in reality it's basically saying 5 waters got stuck onto a CuSO4. So now we have this temporary molecule that's going to be the sum or the addition of all of this. Okay, so the way I like to do it, and you'll see why later on in the year, or if you take a higher level chemistry, it's going to be important to know the individual components. So I do it like this: 1 Cu, 1 S, 4 O, and I'm going to add this up, and it's going to end up being 160 when you're done. You can check your work on that. And then my 5 waters are going to end up being 5 times 18. This is the way we did it earlier, which is going to be 90. And then when I add the whole thing together, I'm going to get 250 grams per mole. Again, this dot, for all intents and purposes, we're just going to say it means add, but it doesn't actually mean that. It's actually telling you that the waters are stuck to, or temporarily stuck to, or glued to, however you want to visualize it. They got tangled together in some way, but they can very easily be separated. And the important part is that no chemical bonds happened here. That's why we're using something other than just sticking them together. Because if we just put them together with no space between them in the middle, it would tell you, or it would try to tell you, that the whole thing is one big compound, and that's not true. It's 5 individual waters and 1 CuSO4. They just happen to all be temporarily stuck together. And that concludes our GFM lesson. There will be a CASA learning on this, which you're going to have to do as well.